So I'm Masanes. I'm working at the Internet and Memory Foundation. And I wanted to present something to you today related to leveraging social media to propel your web campaign, which means basically leveraging the wisdom of the crowd to help you find relevant content on the World Wide Web. And I will actually show you a demo in a few minutes. However, given the discussion this morning, and I've heard of yesterday and before, I thought I would also cover very quickly the topic of how can we work with researchers, how can we provide services to researchers. We have had experience for 6-7 years working with them now at the foundation, and maybe I could share some thought on the model of what we're developing. I don't see anything else. Okay, you see that. I think the web archives have access to the largest, we know that we have the largest corpus of social data ever created, ever accessible. Besides, it's organized in a nice manner. Sorry, I'm going to have to switch on now because I can't see anything. I have to live with it. It's temporally organized. We know how to organize stuff. We have metadata and so on and so forth. And researchers are very interested in that. They are interested in the longitudinal insight we can provide. Either we have had bad experience using or sending arcs and walks to our friends in the research labs, because basically it's putting all the extraction, preparation, indexing workload on there, and they're not so happy about that. Besides, we have also figured out that when it comes to large data sets, and with Web Archive it comes quite quickly with large data sets, it's not so easy to transfer these files through the data link, even if we get good connection overall on both sides. So we have been working on this concept of infrastructure for research for Web Archive as infrastructure for research for a while. And I think, of course, on one side, we need to be able to construct huge data repository and data sets. And for that, we need scalable crawlers. At the Internet Memory Foundation, we are using our own crawler, which we have developed for this purpose, which is a very scalable crawler. But Eritrix we have in this community is already providing a very good tool for that purpose. That we know about. We need to store and organize the data. So what we have done, and I want to share a little bit here our experience for that. We have been looking, of course, at the example of search engine, because they, of course, do lots of things with the data, lots of analysis and so on and so forth by design, and obviously they don't use works. But besides, they don't really keep the data in the same organization. So we're using a big table-like structure, big table being basically a column store organization of data, which is scalable. It really means that you can put, the more server you can add, the more scalability you can have by the system itself. It also provides a way to put content together with metadata very closely in the very same data structure. And it enables you to also scale or increment, if you will, the type of columns, therefore the kind of type of data you want to associate together very nicely. So it's very scalable. Compared to typical data structure like we have in database management system, it's somehow similar in the way it provides you with functions to extract data, store, sort the data. However, it's not as powerful as SQL is. It doesn't allow you to do powerful joint, for instance, and complex things like that. However, most of analytics today, they don't really require that from the outset, at least. So we find it a very useful thing to do, to migrate the content in this kind of structure. And we've done that for 0.5 petabyte of data at this point, and we'll continue to migrate all the content we have. And we have had lots of problems, as you can imagine. So if you are interested in talking to us, or maybe a solution, or maybe you have the same problem, we're happy to discuss these things with you. The other thing is, we believe that it's a good advantage for research and analytics purpose in general to be able to not only store the data and help people find and sort it somehow, but also to be able to execute process close to the data, on top of the data. So here again, we are inspired by the analytical infrastructures of the search engine, which are proven to be scaling to dozens and hundreds of billions of pages. And for that, we have developed, on top of this column store family, an execution chain, if you will, which basically enables us to take any piece of content we have there in a distributed manner and operate any arbitrary sequence of processing, okay? So basically, typical processing would be, for instance, obviously detecting language, extracting text, extracting, as I see Andy has been doing, microformats for location and other things like that. So we have extractors for this, which we can combine in a way. I got something further. And we can compose like that chain of processing so that people come up with new ideas about which part of the data or the structure. Megan mentioned this morning she likes to see the contextual linking and sharing environment per page. Therefore, I think in that case we would, for instance, develop specific extractor to properly detect these so that we can actually count them, for instance, or classify them and so on and so forth. So this infrastructure, for instance, this is an example in the UI for the user, how you can compose this sequence of processing. You have, of course, the source you can define by queries because there's, of course, full text search and search filtering at the basis. So you define your source, and then, for instance, you want to look at the feed extractor. You're looking at feed, how it's been used on the web, and so on and so forth. You want to combine that with information about the MIME type, and you see the feed extractor. Yeah, I have something for that, so let me use that. Okay. The feed extractor, which is this one here, can produce lots of data, and you may be only interested in this one, for instance, just to do a count. Okay, so this is a bit to see the example of sequence of processing. But the point is, whatever research topic or idea or problem you come up with, you should be able to construct a pipeline of processing like that one, so that you can actually apply that to data from the web. So it's a kind of generalization, if you will, to provide researchers or people who use analytics in a way or another to leverage web archive. So it's running on our archive. Typically, the model, we call it unified. This is actually a service we're launching also. Typically, you have these crawls here, which can be, well, for our case, they're obviously web crawls, but it could be actually any source of information. You know, the good thing is when you deal with web data, you actually deal with the most complex data. You can imagine it's pretty heterogeneous, it's malformed, it's horrible, and so on and so forth. So it's good news for you. You're happy about that? No, it doesn't. You should be happy. You've done the worst. Most people, they deal with very clean tabular data, your images, and so on and so forth. We take anything. So that's good for us. That means we can deal with the rest afterwards. So we have this thing here, which is a set of extractor, which we call the baseline, because we apply them to everybody. Every page that comes in the system is treated with these ones. And these ones basically enables us to make the information findable. Okay, so that's the idea of this baseline. So we extract text, for instance, for full text indexing. Therefore, we can do search and filter by search. Okay. We also want to. We also extract, for instance. We extract MIME type. We extract languages. So, for instance, if you want to search on Russian pages that contain certain keywords and maybe a microformat, this is a query. Okay. So all on top of that, you have queries. The point is, here we get tens of billions of pages. We apply these basic extractors also because they go very fast, and we have worked how to optimize them so that they really go sub-milliseconds, and they can really be applied to tens of billions of pages. Then, based on the query you want and the things you want to do, obviously, you're going to select some of them. And that's where the filter and the query engine comes in. It enables you to sub-select the sets of pages on which you're going to make maybe much more costly computer-wise processing. For instance, if you want to do sentiment analysis or semantic type of analysis or multimedia analysis, you know it costs more, CPU, capacity in general. So you may want to apply that to exactly the subset you want. We don't pretend we do sentiment analysis of tens of billions of pages, in other words, or video analysis on tens of millions of videos. However, we can extract to you on some criteria, which we hope are relevant, the subset of thousands or 100,000 on which you're going to be able to make your more complex processing. So that's the model. The idea is also that all this can happen on our servers, close to the data. That means, of course, that we can here process large-scale data, 10 terabytes, 100 terabytes more, because they are running close. Okay, so that. I want to show you a few insights. So if you bear with me, I will show the demo. Bear with me a few minutes more. I will show you some of the results that this kind of architecture enables, if you bear with me a few minutes more. So this is the Aquaman project. It's one of the new projects we are part of with researchers of various countries like Internet Institute Telecom, Yale Research, L3S, and other research centers. Very good guys, doing nice stuff. Few examples so that you understand what this kind of technology and this kind of infrastructure enables you to do. Near duplicate multimedia detection. Here we're typically in a case where it's a costly process. You're going to analyze videos to find out whether they're the same or not. Okay? So it's costly. So these guys, this is Southampton, by the way, the University of Southampton developing this module. They are able to detect that these two videos are the same. Of course, you humans, you find that easy, but computers, they don't. So the interesting thing here, they are all posted, I think, in YouTube, both of them, but they are not posted by the same people with the same comments and with the same number of views. Okay? So from that, you can derive analysis because you know the same piece of video, and those Americans from you, maybe you recognize that. It's something which was important maybe. So from that, you can automatically find in your archive those instances of the same piece of content, and therefore you can start analyzing automatically the context around. For instance, in that case, you will start mining the comments, you will see how much has been seen, and you can start thinking about the circulation of these videos. So that's an example. Another example is the well-known social network analysis. What they have done here, which is interesting, is they have been combining both social network analysis with topical analysis, because you usually have both separated. So the idea is, how do you detect the social network relevant for a given topic and not the social network relevant in general? Okay? So this is an interesting research for which results show that, for instance, obviously the networks change depending on the topic you're addressing. Another funny one, which is, of course, good for us in the archive because we have the longitudinal content insight. And named entity evolution, you can see, of course, change period, and I think, Andy, you've shown something regards the search engine. So here you have to detect, of course, that this guy and these guys are the same. Well, actually, they are the same, but they appear to come to be the same at a certain point in time, where you can find out when it happened. That's when Cardinal Ratzinger became Pope Benedict XVI. Okay? And of course, another interesting thing that is being developed in this research group, that's Athena in Greece. They have developed a marvelous engine which enables you to pose temporal queries, really pure temporal queries, where you don't have any dates in your query. So for instance, when Ratzinger and Pope Benedict are mentioned together, what is being said at the Vatican? So if you think about this query a little bit, okay? Let it sink a little bit. The interesting thing with this query, I didn't mention any time at all, okay? So the point is to ask a system, when some things are being discussed together, I want you to mine these time windows automatically for me so that I can address this other question, which is maybe not directly related, and for which I wouldn't have had any time window to give you anyway. You see my point? So this is very powerful analytics, and it's been written, we've seen that running on a Twitter dataset, and it's very promising technology, which is a bit complex to implement though. Okay, thanks for bearing with me so long, and we now switch to the original topic of this talk, and I will discuss a little bit how we can use a social network, and this is also derived from this project. So, how we can use social media to help us find content. So I've had here the functions of the web archiving process. Of course, we have to find and nominate the content in the first place. So that's why I've had this highlighted at the beginning, because it's quite important. We don't do much on this one in terms of tools. Then we have the collecting, the viewing, and the analyzing function. Everybody's happy with that, I guess? No big surprise. So I think, if you think about, what could I do? No. No, I shouldn't have done that. Okay. Sorry, it's the first time I do a PDF presentation. I'll do that again. Sorry about that. So thinking about what we've done in IRPC, I was thinking, okay, we've been working tools in a very vertical manner regarding this function, if you think about it, right? We've been working on developing tools for collecting, helping us collecting content, Eritrix, of course, the crawlers, and also the tools around the crawlers like the NACAR archive suite. We have our own crawler called MemoryBot here. Then we've been developing tools to view the content, and we have a Wayback Machine here on our toolset, and in internet memory we use a different one. But the point is, we've always addressed this vertically according to a certain function. And there's an interesting example, I think it's been mentioned this morning, which is Navicrawler, which is a tool developed in a research project called eDiaspora. It's an immensely interesting research project, by the way. So Navicrawler is a crawler which helps you analyze the links, and it's a Firefox extension, and it's not developed any longer, unfortunately, but it helps you analyze the links while you select some, right? So you create your corpus by analyzing the connection around the original corpus, okay? So in my view, it's kind of between the finding function and the analyzing function, because it analyzes the links, simple. So the tool I'm going to talk to you about, I asked the team to give me figures until the presentation. They do that. We have developed this tool called, our online SaaS service is called Archive.net, so we are very inventive, and we said, okay, that will be Archive.net version 2. But basically, this is a tool which, again, here, combines finding and analyzing to help this entire process. It's going to be very difficult. So the idea of this tool is to help the librarians and the archivists in a situation which is very frustrating. I'm sure you have had this situation, so I'm going to evoke the situation a little bit for you so that you can remind the pain we have in this situation. 2 years ago, there was the Tunisian revolution going on, and in this country specifically, they use social media much more relatively to the rest than we do, actually. And I was trying to follow that and to archive that, and I think we've been a couple of here to try to follow this event like other events. And this was a very explosive event. It really went very fast. Besides, it was an event where there were likeliness, and there actually was, case where content was withdrawn and could have been entirely withdrawn altogether at some point in time because the dictators in place in these countries, they have some tools to do these kind of things, okay? So we were really thinking, okay, how can we get the content relevant for archiving for such an event, and possibly, if possible, of course, as it happens, okay? And what I realized, compared to campaign I was doing 10 years ago at the National Library of France, but we had this problem already, at least at the time, there were organizations of content through sites which were relevant, right? You had to find hundreds or thousands of relevant sites for a given topic, but when you had them, which we could achieve with, at the time we were 20 or 30 working, for instance, for election campaign, we think we could achieve that with weeks of work, but we could achieve that. What this campaign, this Tunisian revolution showed very strikingly was that actually sharing of content is absolutely disseminated nowadays, right? So, for instance, a huge part of interesting stuff were video posted on YouTube, and of course you're not going to archive YouTube just for that, okay? So you'll have to select to know which videos are relevant and therefore to select them. And same with blog posts or comments and discussion in general were completely split across a huge number of places or big places, but hidden in a huge amounts of content, other content like YouTube. So very frustrating and actually quite a failure in terms of our ability to try to follow it. So the idea we had at the time also inspired this project Arcome I mentioned around the time 2010 and 2011. How can we nowadays make social media and the dispersion of content an ally instead of a problem? How can we make that part of our solution to this problem of finding the relevant content on time? Okay? So the idea, of course, is to use the fact that people are sharing content to piggyback on that, to condense that, to collect all this information and to make sense from a curatorial point of view, from an archiving point of view of that. Okay? So first point, obviously, is how do you follow all what these people are saying? And that's what I did at the time, for instance, for the Tunisian revolution, but then I had even more problems because I started to look at some relevant portal, okay, not lost. Then I found out that there was hundreds of thousands of Twitter people, I don't know if you like that, but that's the way it's called, tweeples, and they were followed by hundreds of people, tweeples, and they were following thousands of tweeples, and I got lost very quickly. I couldn't find the way to move around this huge space of information. So the Arcome project, we put together now almost 2 years and a half ago, people doing research in this area at Institut Ecole Research who are expert in network analysis, and we're asking, okay guys, can you help us here? Could we leverage your methods and your algorithmics so that we can at least find the relevant content very quickly, and also archive it, by the way. So what I'm going to show to you is a kind of illustration of this, because we are arriving at the end of this project, and of course it's supposed to work, so let's go. Okay, so it's organized by campaign, so it's quite different from the usual collection organization. And the idea is you can create your campaign here, leveraging a certain number of, can you see something? Should I, oops. Is that better?
Yeah, please.
Okay, I'll comment on them anyway. So it's a bit broken because I've been zooming a lot. So that's my campaign description. So this is a campaign about the Boston Marathon bombing. And it's typically the case where you'll see the results that it has produced, actually. It's typically the case where you get lost trying to find where the content is. So we are currently only using a crawl, what we call a crawl path, or a path for which we're going to analyze things, which is Twitter, okay? Because we took the low-hanging fruit. Doesn't mean we are going to do Twitter only. We actually want to do everything that is relevant. The same method applies, okay? So the idea is defining, based on your path or a type of network you're going to leverage, you can define some criteria. So in that case, you can use hashtags because it's Twitter. You can also use the keywords and languages. Okay? So this looks like a dumb API connector to the Twitter API. It is not. Okay? There are several reasons why it is not. The first reason is because we want to control the logic and the intelligence of the selection. So, as I will explain, the intelligence of the selection is done on our side, not on Twitter. Some of what we do, actually we could do just using Twitter API, but we prefer to control the intelligence of the selection ourselves on our side. Okay? It's all about threshold and other thing I will explain a bit later. The second reason, which is pretty fundamental, is that Twitter might close their API anytime. Actually, they already put heavy restriction on use of their APIs, which they didn't at the beginning, and they might change. So we want something which is resistant to the change of mind of this big company, which used to be not so big, but are getting big. Okay? You define your target, you set up your campaign, and then you get in a discovery phase. So here, I think I will have to. I'm going to keep on the archive. I've made another web archiving, for instance, here. We'll go back to Boston, because there's a difference in pattern. Sorry, if I zoom too much, you lose this, which I would like to comment. Okay. So basically, what it does, it finds the Twitter core, which is the sets of people talking about this topic. Okay. So how do we do that? It's currently under investigation. There's lots of very complex algorithms which we have learned and worked with our friends in this project, but actually we started implementing ourselves the simple things, the basic stuff, okay? And it's going to be different by domains or by the type of social network you leverage, obviously. But currently what we do is we use a two aspects, two characteristics of this construct of the conversation. We use the connectivity, the social network, the graph analysis, if you will, and we use content analysis. So we have developed a topical detector, which basically creates vectors on your content on the campaign, and it enables you to tell, okay, this guy or these tweeples are talking about your content, you know, once in every 20 tweets. So actually, they're not really on the topic. Okay. It enables us also to filter down the line the pages that will be found through the system, as I will explain. So basically, what we have here is a set of people who talk a lot about this topic. Okay? So currently, we are still trying and figuring out which iteration we should make to renew this core group, to make it evolve through time, and so on and so forth. So there's lots of parameters all over the place in very remote places. So the idea is to construct this core of users we monitor and we follow somehow, so that they produce the relevant linking for us. Okay? So that's the general idea. And that's what you have here. Here you have a little view on the tweets that these people are producing to be sure you are on topic. Okay? It's just a verification mechanism. Besides, we also generate these keywords, whatever cloud or thing, so that you get an idea of whether you are on the topic or you're not, or there's something wrong. Here you get an idea of how productive your system. These are the numbers of URLs that these people are producing for you on the topic per hours. Okay? So here you can find web archiving, you see, okay, 20, 16, 18, and so on and so forth. Not so much. If we go back to Boston, we'll find out that there's much more. If it wants, sorry. Doesn't seem to want to come. There's much more. I will have some figure at the end. And obviously, what we want to check at the end is that the pages that these, or the items of content that these people have found for you are relevant. And of course they are not, because these people are talking about lots of things. Even if they're upset by the Boston Marathon, even during these few days here, they might actually share some links which are completely unrelated for a video or a post about something which has nothing to do with the topic. that's why we have a second step for which we leverage the infrastructure I've told you, where I've shown you before, where we actually detect the topic on the page themselves. So we expand the shortened URLs, we crawl them, we check they are on topic, and if they are not on topic, we don't count them. Okay? So these tools generate thousands and thousands of relevant URLs. And one thing maybe you're not going to see is how dispersed they are. I think there's a few sites which come twice in this list actually. And there are some you might have thought of, like news media and so on and so forth, but there's lots of them which you might never have found or find easily anyway. Okay? So this system is working for you. When you set up your campaign, you decide what are the keywords, what are the directions you want the system to work with you. It's working for you. It's finding content for you. And I will show you to finish a few stats, which are, they're worth what they're worth because we are still working on the system. But for instance, in a day, the total tweets we got for Boston was almost 20,000. And out of this, we've discovered 13,000 URLs. As you can see, it's quite a lot. And the web archiving topic is less active, but it's kind of okay. Okay, so this is the important figure, and then I will be done. We want to know whether this system is efficient, right? Efficiency means it will find for me automatically all the relevant content wherever dispersed it is, thanks to the help of all these people interested in that and specialists in that, okay, all over the system, the social network, okay? So to get an idea, and this is again first results, but to get an idea, what we need to measure obviously is the URLs or the piece of content, if we will, which you have here. Watch out, it's a logarithmic scale, okay? So this is 100,000 and this is 10, okay? And here you get the threshold for which our topical matcher has been determining the corresponds to the topic or not, okay? And there are different patterns of distribution here. It depends on whether the threshold is, very well defined and so on. The topic is very highly and well defined and so on and so forth. The interesting figure here is you can see if we don't set any threshold, launching the system on the Y or almost on the Y, just using the Twitter API actually as a start, we would get actually close to 1 million euros very quickly. Actually, we have done this crawl for real. So we got this kind of measure here. I don't know if it's going to the million, but it's well above the 100,000 euros for Boston, okay? Using the Twitter API without any further distillation, okay? Here, thanks to our topic matcher, we could set threshold, for instance, to 8.8, and we would get something like 1,000 of pages or item of content. I bet this would be highly focused. And I wouldn't take much risks in archiving them systematically. Okay? So that's the point, because if you launch your beast, even starting from a good API like Twitter, it goes, the beast being the crawler, and we know how, they are. They go in many directions, and even Twitter doesn't provide you raw with, something very useful anyway. If we use this system to adjust the parameter and to keep the intelligence of the selection of the tweeters, triples, and of course of the filtering and the logic of the filtering in terms of criteria and the weighting of parameters and criteria, then we can achieve, more or less what we want. We could set out, okay, I think I would get to 10,000. I will have a bit of noise, obviously, but I'm okay with that. Or no, I can't afford to have noise. And we have Elasticsearch behind the scene running to run all this, in addition to the filtering. So, if you set it up here, you're pretty sure you get something like the 1,000 most topical if you can have only 1,000 items of content for this particular topic. So maybe we'll actually implement a budget function so that you can say, okay, I get my budget of 1,000 items of content for this topic, give me the 1,000 which are the most relevant. Leveraging the crowd of social networks. And again, we're not going to be limited to Twitter. And using this system, you can actually achieve to find content, whatever dispersion it has, okay? There's, of course, lots of things you can do starting from here. So I will finish by a little bit of what's coming next. First, we'd like to launch this service as a beta so that people can start playing with it and figuring out whether it works for them or not. As you have seen, there's a function which enables you to export the seed list, where there will be also a function to export the ARC, the content, the archive content. If you do yourself archiving, maybe you don't want to export ARC content, maybe you just want to export the seed list, so it can be useful. And of course, for researchers, it should be able to, of course, monitor permanently with a set of criteria which are well-defined and constant somehow, a certain topic, to give a sense of this comparability and reference that we need for the type of research. We are going to extend that to other APIs and other systems. Remember, I told you that it's important to not to be too dependent on Twitter. Actually, I think this one we could even run it without the API at all. So I'm, preparing for being blacklisted. I don't know, maybe we won't, but we might be. So we're prepared for that. So we are going to extend to other social networks. And obviously, we want to enable more analysis and classification further down the road using this infrastructure. Okay, thanks a lot for your attention. I'll just show you a little bit of our new servers because they are so cool and so nice. They're symmetric, yes, believe me. So when you come in Paris, you'll be able to see some. They are here finally, Alan. Yes, they are. And our little team here in Paris. Thanks a lot for your attention.